Hello students, you are welcome to the YouTube channel Physics for Everybody. Today we'll be going through how you prepare for your Year 10 examinations and your tests. So this preparation for your exam will also help you to prepare for your IGCSE in the long run. So if you're in Year 11 or you're preparing for IGCSE, this video also suits you because we'll be covering so many topics: electricity, density, work, energy, power, motion, speed, velocity, acceleration, graph, on and on and on. Let us start with the first question, multiple choice, electricity. Question number one. The circuit shown includes two meters, X and Y, connected correctly. Which row gives the unit of the quantity measured by X and the unit of the quantity measured by Y? Okay, so X, looking at the diagram, X is connected in series in the circuit. Y is also connected in series to the ohmmeter, to the resistor in the circuit. And which instrument do you connect in series? The instrument to connect in series is the ammeter. That's the instrument in series. That means X is an ammeter, Y is also an ammeter. Okay? So now, what is the SI unit of what you measure with the ammeter? Is measured in amperes. So A is the correct answer, okay? Because X measures ampere and Y also measures current in amperes. Question number two. The diagram shows two resistors connected in the circuit. These are the two resistors. Question: what could be the combined resistance of this arrangement of resistors? How do you solve the combined resistance? The formula is R1 multiplied by R2 divided by R1 plus R2. That's how you solve questions involving two resistors in parallel. You see that these two resistors are connected in parallel. Yes, if they are connected in series, the circuit will look like this, and you have one wire coming out from the cell. It goes through the first resistor and it goes through the second resistor and then back to the circuit. These two resistors are in series. So if the circuit was like this, the combined resistance would be R1 plus R2. So you add it. If they were like this, you take this as your R1, you take this as your R2, you add the two values, okay? But now let's get back to our question. Since in our question, the electric circuit shows two resistors that are connected in parallel, this is the formula we'll be using, okay? So what is the value of our R1? R1 is 6 ohms. So we have 6, R1 is 6.0, 6 multiplied by, yes, R1 is 6.0, while R2 is 12 ohms. So we have 6 multiplied by 12 divided by 6 plus 12. 6 multiplied by 12 gives us 72. 6 plus 12 gives us 18. 72 divided by 18, that should give us 5. Am I correct? No, that's not 5, that is 4. 72 divided by 18 will give us 4 ohms. Ohms, SI unit of resistance is ohms. So A is still the correct answer to number 2. Question number 3. Which produces an electromotive force, EMF, in a circuit? Is it the battery? Is it the filament lamp? Is it the resistor or the spring? The filament lamp, sorry, the battery produces the EMF in a circuit. Question number 4. The diagram shows a 40 ohm resistor and a 60 ohm resistor connected in parallel. Which is the total resistance between point P and Q? Okay, you can see that this circuit, if the circuits look like this, like you have one wire going through, connecting the two resistors, then you know they are in series, okay? But in this case, they are in parallel, okay? We take this as our R1, we take this as our R2, the 40 ohms resistor is our R2. So which formula will you be using? You use the formula for solving question involving resistors in parallel. And which formula is that? That is R1 multiplied by R2. This is not good enough. R1 multiplied by R2 divided by R1 plus R2. So that's the formula we're using. Now let's substitute. So you have 60 multiplied by 40 divided by 60 plus 40. 60 multiplied by 40 will give us 2,400. 60 plus 40 gives us 100. So if you divide 2,400 by 100, you get 24 ohms. So what are the options? Option A, less than 40. That is correct. 24 is less than 40. Okay. B, 50. C, between 60 and 100. D, 100. No. Only A is correct. Now let's go to question number 5. A circuit is set up to determine the resistance of a resistor R. The meter readings are 2.0 amperes and 3.0 volts. So this is the circuit. Now the question, what is the resistance of the resistor? You solve this question using Ohm's law. And according to Ohm's law, the mathematical expression of Ohm's law is V is equal to IR. And that also means that resistance is equal to voltage divided by current. Okay, so let me put the division sign here, let me put the division sign here, and multiplication sign here. So this is the visual representation of Ohm's law. According to Ohm's law, V equals to IR. Okay, so if you're looking for resistance, this is the formula you use. R is equal to V divided by I, the voltage divided by current. Now in this question, the voltage is 3.0 volts, so you have 3.0. The 0.0 is not necessary, it's just decimal point. Divided by our current is 2.0 amperes. 2.0, the 0.0 is not necessary. If you do 3 divided by 2, you get your answer, 1.5 ohms. That is the resistance of the resistor. Let's check our answer. 1.5 ohms, that's option B, correct. Now we are going to solve some multiple choice questions. Question number 1. Question number 6. Professor Ejairo uses an electric pumping machine in Makurdi for 90 minutes. Given that the pumping machine is rated at 1,600 watts, how much would Professor Ejairo pay for using this pumping machine? You are given that electricity is being charged at the rate of $4 per kilowatt hour in Makurdi. The question is, how much would Professor Ejairo pay? How much? That means they are looking for the cost. And the formula for calculating cost is that the cost equal to the energy in kilowatt hour multiplied by the rates that you pay for consuming the energy. Now, according to this question, how do you get energy? Electrical energy is IVT, okay? And if you get your IVT, you have to divide by 1,000 to convert to kilowatts, okay? Don't forget that your time must be in hours. So now let's do our IVT. Your current, our current is, what's our current? Do you have our current? No. Do you have our voltage? No. What we have is power. So that means we don't need to use IVT because we don't have current, we don't have voltage. What we have is power. Another formula for energy is power times time. But do not forget that your power must be in kilowatts. Okay? So, what is our power in this case? Our power is 1,600 watts. To convert to kilowatts, you divide it by 1,000. That will give you 1.6 kilowatts. That's our power, 1.6 kilowatts. The second thing you get is our time. What is our time? Our time is 90 minutes. To convert from minute to second, you have to to convert from minute to hours, you have to divide by 60. So if you do 90 divided by 60, you get 1 1.5 hours. Now, this is what we are using to solve this question. Now, coming back to the formula for calculating energy. What's the formula for calculating energy? Energy is equal to power times time, okay? When you get the energy, then you come and substitute the energy here. Yes, that's what we'll be doing. So let's go back to our calculation on energy. Energy is equal to power times time. I'm working with this box. What's the power now? The power is 1.6 kilowatts. So you put 1.6 here, 1.6 multiplied by, energy is power multiplied by time. What's the time? The time is 1.5 hours. So you put 1.5 here. Okay, good. Multiply 1.6 kilowatts by 1.5 hours. Let us see what that will give us. 1.6 multiplied by 1.5. We got 2.4. So the power is 2.4 watts. So our power is 2.4 watts. We put 2.4 here. 2.4. Now, not watts, kilowatt hour. That is the energy. Yes, the energy is 2.4 kilowatt hour. Now, how do you get cost? Going back to the first formula, which is this formula. This is the formula we are using to calculate the costs. And cost is energy multiplied by rate. So that means the cost is your energy multiplied by the rate. And how do you get energy? You've gotten the energy already at 2.4 kilowatt hour. Multiplied by, what's the rate? Energy is being charged at the rate of $4 per kilowatt hour. This is the rate. Okay, the rate at which energy is being charged. $4 per kilowatt hour. So you multiply this by 4. 2.4 multiplied by 4. That will be 9.6. Yeah, that will be 9.6. So the amount Professor Ijaro will be paying will be $9.6. So that is it. Okay, so let's go to the next one. Calculate the cost of running an electric fan rated 2.5 kilowatts for 15 hours, given that the power holding company charges 8 naira per kilowatt hour. How do you calculate the cost? The formula remains the same. Cost is equals to the rate multiplied by energy. Okay, or you say cost is energy multiplied by rate. Whichever way you state the formula, you are correct. Okay, so whichever way you say cost is rate multiplied by energy, or you say cost is energy multiplied by the rate. Now, what is the energy? Energy is equal to power times time. If you look at this question, you see that the power is 2.5 kilowatts. Yes, power is measured in watts or kilowatts, while the time is measured in hours. The time is 1.15 hours. That's the time. The time is 15 hours. Okay, so we have our power as 2.5 kilowatts and our time is 15 hours. So how you get the energy? Energy is equal to power, which is 2.5, multiplied by the time. The time is 15 hours. If you multiply 2.5 by 15, you will get, let me do that here, 2.5 multiplied by 15. That gave us 37.5. So you have 37.5 kilowatt hour as the energy. 37.5 kilowatts hour. Now, to calculate the cost, which formula are we using? We are using this very first formula to calculate the cost. So the cost now is, do not forget that this is the rate, okay? This is the rate at which the power is being consumed. So our cost is equal to the energy, okay? The energy multiplied by rate. What's the energy? The energy is 37.5 kilowatt hour. So here I write 37.5 multiplied by the rate, and the rate is 8 naira per kilowatt hour. Now when you multiply 37.5 by 8, what will you get? 37.5 multiplied by 8, that gave me 300. So the cost is naira 300. If you have written 300 naira per kilowatt hour, that will be wrong, okay? Because naira per kilowatt hour, that will be the SI unit of rate, not the SI unit of the cost itself. Okay, when you say cost, we are talking about financial value, which is money, and you cannot measure money in naira per kilowatt hour. No, you can't measure money in this unit, so you cannot put that unit here. No, that's not the unit of money, that's the unit of rate, okay? Your money must be in currency, okay? Be it naira, be it dollars, be it pounds, depending on the question. Question number 8 says, Chukwuemeka uses a refrigerator in London for 2 days. Given that the refrigerator draws an electric current of 9.5 amperes from a 240-volt power supply, how much would Chukwuemeka pay for using the refrigerator? Note that electricity is being charged at the rate of 0.55 euros per kilowatt hour in London. Okay, this pounds, 0.55 pounds per kilowatt hours in London. So what will you do? The formula remains the same. Cost is equal to energy multiplied by time, multiplied by rate. What formula for energy? Are you going to use power times time this time around? No, because you don't have power. What we have is the current, we have the voltage, and we have the time. So what you do is IV divided by 1000, okay? That's in order to convert your power, in order to convert your energy, your power to kilowatts, yes. IV will give you your power in watts. If you multiply current times voltage, you get your power, but it will be in watts. And in this topic, we don't use watts, we use kilowatts as the unit of power. That's why we are dividing by 1000 here to convert to kilowatts, okay? Now, the formula for energy is current times voltage times time. So you have to include time here. But do not forget that your time must be in days. No, sorry. Do not forget that your time must be in hours. But in the question, the time is in days. So you have to convert from days to hours. That is what you'll be doing here, okay? So let me solve that right now. Let us start by converting our time from days to hours. Do not forget that your time is 2 days. That will be equals to 2 times 24. Yes, because 24 hours make 1 day. So you multiply 2 by 24. That's how you convert it to hours. You get 48 hours. Okay, so now you can now calculate our energy by saying our energy is equal to your IVT. The current, what is the current? The current is what? The current is 9.5 ampere. So you have 9.5. You know, you are multiplying current by voltage, right? What's the voltage? The voltage is 240 volts. 240. Now you are dividing by 1000. Okay, according to the formula, you are dividing by 1000 in order to convert to kilowatts. Now you multiply it by what? You multiply it by the time. Multiply by time. Do not forget that your time is 48 hours. So to make our work easier, you just multiply 9.5 multiplied by 240 divided by 1000. 9.5 multiplied by 240 divided by 1000. That gave us 2.28. So if you multiply, that gives us 2.828. So if you multiply 2.28 by your time, which is 48, okay, 2.28 multiplied by 48, you will get 109.44. So we have 109.44 kilowatts hour. How do you calculate cost? Cost is energy multiplied by time. So you multiply your energy is 109.44. Sorry, cost is energy multiplied by rate. Cost is energy multiplied by rate. This is the formula for calculating costs. Multiplied by the energy by the rate. What's the energy? The energy is what we've just calculated there, 109.44. What is the rate? The rate is this 0.55 pounds per kilowatt hour. This is the rate. Okay? So you multiply by 0.55 pounds per kilowatt hour. So that's what we are doing here. Multiply by 0.55. So let's go. Multiply this value by 0.55. What you get is 60.192. You can write it to two decimal place. Naira, no, pounds. 60.192. 60.19. Okay, so write it to two decimal places enough. 60.19. That's the answer here. Now we're going to be solving questions on density. Figure 3.1 shows an oil tank that has a rectangular base of dimension 2.4 by 1.5 meter. The tank is filled with oil of density 850 kg per meter cube to a depth of 1.5 meters. Calculate the pressure exerted by the oil on the base of the tank. How do you calculate the pressure here in this fluid? Pressure in fluid is given by density times gravitational field strength multiplied by height. What is the height? The height is from top to bottom here. Sorry. The height is from bottom to the top of the container, which is 1.5 meters. That's the height. So pressure is density, which is 850, multiplied by G is gravitational field strength, which is always 10, multiply it by the height, which is 1.5 meters. So if you multiply 850 by 10 by 1.5, what will you get? I got 12,750 Newton per meter squared. So that is the pressure. So 12,750. Pressure is measured in Newton per meter squared. So you have to put your SI unit there. Okay, 12,750 Newton per meter squared. The next question says, the force exerted by the oil on the base of the tank. How do you get the force? Remember that pressure is force divided by area, right? Good. That means to get force, force is equal to pressure times area, where the area A is the base area of the tank, which you get by multiplying the length by the breadth. This is the length, 2.4. This is the length, 2.4. And this is the breadth, 1.5. Okay. The area is that is the base. Okay. If you try to reproduce this base, and this shaded portion represents the area of the cuboid. So how do you get the area of the cuboid? You know the shape of the shape of this base of the cuboid is the shape of a rectangle. And to get the area of a rectangle, you multiply the length by the breadth or by the width. So we have 2.4 multiplied by 1.5. That will give you the area, okay? 2.4 multiplied by 1.5, what will that give you? 2.4 multiplied by 1.5 give us 3.6. So the force equal to the pressure, which is already 12,750 multiplied by 3.6. Do not forget that we got 3.6 for the area, right? Yes. When we calculated the area, we got 3.6 meters. So that is what we are doing here. So if you multiply 12,750 by 3.6, what will you get? So when we multiply, we got 45,900, and that is our answer, 45,900 Newton. The SI unit of force is Newton. The next question, the force calculated in AII is the weight of the oil. Calculate the mass of the oil. You know, weight is equal to mass times gravitational field strength. Now, you've been told that the weight is equal to this force, okay? Which is actually correct because weight is measured in Newton, just the way force is measured in Newton. Now, if you calculate to calculate the mass is to get mass, to make M stand alone, you know, this formula can be written as mass times gravity is equal to weight, right? To make mass stand alone, you divide both sides by G, which is gravitational field strength of the earth. When you divide that way, you have M equals to W over G, and that's how you get your answer. What's the weight? The weight is 45,900 divided by G is gravitational field strength, which is always 10. Okay, hence your answer will be 4,590. Your answer will be 4,590 kilogram. Yeah, that's the SI unit of mass. Mass is measured in kilogram. Now, the next question. When he is checking the level of oil in the tank, a man drops a brass key into the oil and it sinks to the bottom of the oil. State what this shows about the density of brass. If something is sinking in an oil, then that shows that that thing is denser, okay? That shows that the brass is denser than the oil. That's it. Explain how attaching the key to a piece of wood could prevent the key from floating. The piece of wood, let me just write the wood here. The wood has very low density. Yeah, so its density is lower than the density of the oil. So the density has density, or you say the density of the wood is lower than the density of the oil. So the density of the wood is lower than density of the oil. So hence the resultant density of the wood and oil is lower. I mean the resultant density of the wood and the key is lower than the density of the oil. That's why the key and the wood will float if the total density, that's the average density of key and wood together, if it is lower than density of the oil, then it will be made to float. Okay, this is the second question on density, and it says, a student wishes to find the volume of a piece of wood of irregular shape. Her experiment requires the use of a small brass object of mass 200 gram. Calculate the volume of brass object and you are given that the density of brass is 8.4. You know density is mass divided by volume. That means to get volume, you say volume is equal to mass over density. That's all. So you divide the mass by the density, you get the volume. Okay. What's the mass? 200 grams. What's the density? 8.4 gram per cm cube. 8.4. If you divide 200 by 8.4, you have 200 divided by 8.4. Let's see. 200 divided by 8.4. You get 23.809. So you can write that as 23.81. And if you want to write it to two significant figure, that will be 24. So you write 23.81 cm cube. That's our answer, okay? So you can write that in the space provided for answer, 23.81 cm cube. To find the volume of the piece of wood, the student has a measuring cylinder, a supply of water, and the brass object in A. The piece of wood and brass objects are small enough to be placed in the measuring cylinder. The piece of wood does not sink in water. Suggest why. Why wouldn't it sink in water? This is because you don't need to write all of this grammar. Go straight to the point because wood, I wasn't supposed to start from there. Because wood is less dense than water. Sorry, yes, that's correct. Wood is less dense than water. That's why it will float. The denser one will go down to the bottom of the water. Describe what the student does to find the volume of the piece of wood, stating measurements that she makes and any calculations required. The student will initially fills a measuring cylinder. Initially fills a measuring cylinder with water. With water. So now after filling with water, what's the next thing? The student ties the the piece of wood and the brass object together. So after that, the student will completely submerge it, comma, and completely submerge it in water. In the water, submerge this in the water in the measuring cylinder. Read read the water level or the level of water as V1. Let's take that as 70 cm. Okay. After that, now tie the okay. So initially, the student fills a measuring cylinder with water. Then the student now ties the student now ties the student now ties the brass object. Yes, sorry about this. This is not good enough. The next thing is that the student now ties the brass object with a rope, comma, submerges it in water. So you completely submerge it in water in water in the measuring cylinder, then read its volume. Okay, and read its volume. Volume. So you read its volume V1. You can take that as 50 cm, 50 cm cube. What's the next thing? Okay, now you now tie the brass object. The student then ties the brass object with the wood, submerge it in water, and read its volume. V2 equals to, let's call it 70 cm cube. The question says, describe what the student does to find the volume of the piece of wood. So what will now be the volume of the piece of wood? Volume of the piece of wood is equal to 70 minus 50, and that will give you 20 cm cube. Good. This is how you find the volume of the piece of wood. Why? Because if you have a measuring cylinder and you put only the piece of wood in the measuring cylinder, the piece of wood will just float in the surface of the measuring cylinder. Okay, but when you tie the piece of wood you tie it to a brass object and then you dip it in water, it will be forced to sink to the bottom of the water. Okay, when you tie it to a piece of brass, okay, so your piece of wood will be forced to sink with the brass. Okay, initially this was the level of water, okay, before putting the brass. And when you put the brass and water, when you put the brass and the stone, the water level will rise to a second value V2. Okay, the first value was V1. That's the initial volume before the volume of the wood was added, which made it rise to this level. So your change in volume will give you the volume of the wood. Let us take the next question. Now you are dealing with motion. A bus travels at constant speed. It stops for a short time and then travels at higher constant speed. Using the axis in figure 1.1, draw a distance time graph for this bus journey. Okay, how do you draw a distance time graph? The bus is traveling at constant speed. That's what this straight line shows. Okay, you don't shade the line, you use a straight line with ruler and pencil in your example. It stops for a short time. This shows that it stops for a short time, then travels at a higher constant speed. Travels at a higher constant speed. So the steepness of this slope shows that the speed is higher. Okay, and you have answered the question. You have drawn the distance time graph. Okay, you have answered the question. Let's go to the next question. Question number, the second part of the question. A lift elevator starts from rest at the ground floor of a building. Figure 1.2 is the speed time graph of the motion of the lift elevator to the top floor of the building. Now this is the question. Use the graph to determine the distance from the ground floor to the top floor of the building. When you are trying to determine the distance traveled on the graph, distance is equal to area under the graph. Area under the graph, okay? Or you say area under the slope. And how do you get the area under the slope? That is the area of this triangle. Okay, so let me zoom into this so I can see the triangle clearly. I say triangle, so I can see the trapezium clearly. Now this is the trapezium, okay, so you have to read our values of A and B so you can calculate the volume successfully. Yes. What is the formula for volume of a trapezium? Volume of a trapezium is equal to half open bracket A plus B close bracket multiplied by height, okay? This is the A, the topmost part of the graph. This is the B, the lower part of the graph. And the height H is this distance I marked with the dotted line, okay? The length, the distance gives you the value of H, okay? Good. So let me erase the formula and go ahead to substitute. If you look at this diagram, this is your A, this is your B, yeah, and this is your H. Now let us calculate the volume from this data given. Sorry, let's calculate the area. Area equals to A. What's the value of A? A is from this place to this place. And what value do we have there? That will be 20. That will be what we have here, which is 20 minus what we have here, which is 7.5. So A is 20 minus 7.5. That means A is 12.5. Okay, B is the from the left hand side to the right hand side, and B is 25. Okay, good. B is length from here to here, and that's 25. So you can put that here, 25 multiplied by the, sorry, that was a mistake. I shouldn't put multiply there. It should be addition. Addition. Okay, addition 25. Then in the bracket, I put the height there. Do not forget that this is the formula we are using for the distance. Half open bracket A plus B close bracket multiplied by H. How do you get H? H is the height from bottom to the top, and that gives us this value here. What value do you have here? That will be 3.3. That's the value you have there, 3.3. So you multiply it by 3.3. 12.5 plus 25, that will give you 37.5. Multiply by 3.3. 37.5 multiplied by 3.3. 37.5 multiplied by 3.3. 37.5 multiplied by 3.3. 123.75. So our answer is 123.75. Okay, 123.75. So that's it. Easy. And the next question, which says, figure 1.1 shows the speed time graph for a car traveling along a straight road. The graph shows how the speed of the car changes as the car passes through a small town. Question: calculate the distance between the start of the town and end of the town. Now, if you look at this graph, you see that this is the start of the town. Here, this is the start of the town, and this is the end of the town. Okay, good. So that's how you get the time. Okay, and if you want to get the speed, you trace this graph here, constant speed up to this place. This is the speed. The speed is 16. So to get distance, you calculate the area of this shape. What shape is this? This is a trapezium. So you calculate the area of this trapezium. Okay? Do not forget that the length of the trapezium is from here to here, which is what? 10, 20. Which is 24 seconds. I hope I'm correct. Okay, that's 24 seconds. And our time is 14. No, our time is 16. So you calculate the distance, or you just use the formula u plus v over 2 multiplied by t. Okay, where u plus v are the constant velocity. Okay, u is the velocity of 60 meters per second, v is velocity of 16 meters per second. Let's go. So you have 16 plus 16 over 2 multiplied by the time taken. And we know already that the time taken is 16, right? So you have 16 as the denominator, which is time taken. No, it's not 16. This is 10. You know, from 0 to 5, there are 10 boxes. That means each box will be 0.5 units. So if this is 10, the next two will give you 11, the next two will give you 12, the next two will give you 13. That is 13 meters per second. So I'll go back to that and I put 13 there. So the speeds are 13 meters per second. So in this topic, it is very easy to make mistake. You have to be very careful. And the time taken is 24. Yes, that is correct. 24. So 13 plus 13 divided by 2, that's just 13 times 24. And what will that give you? We got 312 meters. Calculate the acceleration of the car between C and D. How do you calculate acceleration of a car between C and D? Okay, C and D. You have to get the time taken first of all. You have to know the timestamp where D is. After knowing that timestamp, the problem is solved. Don't forget that the question says calculate the acceleration of the car. How do you calculate acceleration? V minus u divided by t, right? So what is our V? So our V is 31 and our u is 13. Just as we figured out here. Let me erase all these things that can cause confusion. So our u is 16 and our V is 31. So we have 31 minus our u, which is 13. So the acceleration is v minus u over t, and that will be 31 minus 13, all divided by, how do you get the t? The time is recorded there. How do you know the time? The time is from here to here. And what time stamp do you have there? 10, 20, 12, 12, 12. Yes, from the beginning, which is here, to end, which is here, is 12. Okay, yes. So our time taken is 12. So you go back there and you put 12 there. 31 minus 13, what would that give you? 31 minus 13, then you divide it by 12. 31 minus 13 gives us 18. By the time you divide 18 by 12, by the time you divide 18 by 12, that will give you 1.5 meters per second. Now the last question states how the graph shows that the deceleration of the car has the same numerical value as the acceleration. How do you know that deceleration, okay, which is negative graph, it has the same thing with the acceleration? When is the car decelerating? Down here, the car is decelerating. When is it accelerating? Up here, is accelerating. So how do you know that is decelerating? If you calculate the slope of this shape, if you calculate the slope of this shape, you get the reason. You get negative of whatever you get. And if you want to try it, let's try it out. Slope is equals to v minus 0 over t. And what is our v? If you look at the question, you realize that the v is the final value, which is 13, and the u is 25. The u is 25. 13 minus 25 divided by, what's the time taken? The time taken from this graph is the time taken for the deceleration to occur. That is from 10 to 18. Okay, 18 minus 10, that will be 0.8. Sorry, 18 minus 10, that will give you 8. So you go and put that 8 in this expression, 8. 13 minus 25 will give you minus 12 over 8. And minus 12 divided by 8 will give you minus 1.5. So deceleration has the same numerical value as acceleration. Okay, good. State how this graph, okay? State how the graph shows that deceleration of the car is the same numerical value as acceleration. We say the steepness of the slopes at both sides are equal. So that's it. That's the solution to the last question. So far, we have solved questions on motion, speed, velocity, and acceleration. We solved questions on graphical method of solving question on motion. We solved questions on density. We solved questions on pressure. We solved questions on yes, mass and weight. We also solve questions on costing, how you calculate the costs of consuming electrical energy and power. Finally, we solve questions on electricity. Thank you very much for listening attentively. Do have a nice day. Hope to see you during the next discussion. Goodbye.